When you're transforming circular functions, you can do it in exactly the same way that we've been doing transformations throughout the whole year. So let's do this one. Find the equation of the image of this under the following transformations. It's dilated by a factor of 2 from the x-axis. So dilations from x change y, so that's going to be x to y. Dilated by a factor of 3 from the y-axis, so that's going to be 3x to y. And translated 5 units in the positive direction of the y-axis. Positive direction. And 2 units in the negative direction of the x-axis in that order. Okay, remember that's x dash and that's y dash. So I just write out x dash equals 3x take 2, y dash equals 2y plus 5. Now what do I solve for? Well, I'm trying to make my new function from this. That means I need to find something for y and something for x. So that's telling me that I need to solve for x and solve for y. So that's going to be 3x equals x dash plus 2, x equals x dash plus 2 on 3. This one over here is going to be 2y equals y dash take 5, y equals y dash take 5 over 2. All right, now we're ready to substitute, and I'm going to make my new function. I'm going to drop these dashes straight away. All right, so what I'm going to do is write y take 5 on 2. So I've substituted that into that and just remove the dash straight away to make my new function. Equals sine of x, which is x plus 2 all on 3. All right, so now all I'm going to do is make y the subject, y equals sine x plus 2 on 3. That's going to be multiplied by 2, and that's going to have 5 added to it. So there's my new function after it's undergone all of those transformations. Okay, another one. So we're still transforming y equals sine x, but we're doing this time. So dilated by a factor of 3 from the x-axis. So dilations from x change y. So that's going to be x 3y. Translated pi units in the negative direction of the x-axis. So x take pi, 3y. Dilated by a factor of a half from the y-axis in that order. So we're going to go half x take pi, 3y. That's x dash and that's y dash. So x dash equals half x take pi and y dash equals 3y. Y equals y dash over 3 and x equals 2x dash plus pi. All right, ready to make those substitutions, remembering that we were subbing in for y equals sine x, I think. Just double check that. Yep. So where I see y, I'm going to put y dash over 3, but I just want to drop these dashes straight away. So I'm going to say y on 3 equals sine of 2x plus pi. So I've replaced x with this new one here, and I've removed the dash. That's y equals 3 sine 2x plus pi. Done. Find the equation of y equals cosine x under the following transformations. Dilated by a factor of 3 from the x-axis. Dilations from x change y. Translated 2 units in the positive direction of the x-axis. Dilated by a factor of 1/3 from the y-axis. Dilations from y change x. 1/3 x plus 2, 3y. And finally, 4 units, translated 4 units in the positive direction of the y-axis. So that's going to be 1/3 x plus 2, comma 3y, 4 units in the positive direction of the y-axis plus 4. That's x dash, that's y dash. X dash equals 1/3 x plus 2. All right, now let's make x the subject because I want to sub for x and sub for y. So I'm going to go 3x dash take 2 equals x, and I'm going to go y dash take 4 on 3 equals y. All right, let's make the substitutions and drop the dashes. Y take 4 on 3 equals cosine 3x take 2, y equals 3 cosine 3x take 2 plus 4 as our new or transformed function. Take the sequence to go from this to this. So we're going to go from y equals sine x to y equals negative 2 sine 3x plus 2 take 1. So from this to this, okay, so this is the original, this is the image. So let's pop some dashes in there. All right, and what we'll do is get these ready for pairing up. So y dash plus 1 over negative 2 equals the sine of 3x dash plus 2. All right, so now we're going to pair the y's with the y's. Y equals y dash plus 1 over negative 2, and x equals 3x dash plus 2. All right, so remember what we wanted to do was state the transformations. So x, y, x dash and y dash. So it would be these things here, that would be the transformations. So that tells me I need to make x dash and y dash the subject to slam in the kind of transformations. So let's do that. I've got negative 2y take 1 equals y dash, and I've got x take 2 over 3 equals x dash. Right, so let's pop that in. X take 2 on 3 and negative 2y take 1. All right, let's have a look at this. All right, so what happens with this is, first of all, it's going to get shifted. How many units is that? That's 2 units to the left, and then the result is going to be multiplied by a third, okay? So we're going to say the following. So here's the first transformation. We're going to say translated 2 units to the left, and then it's dilated by a factor of 1/3 from y-axis. Okay, so 1/3 from y because dilations from y change the x value. Right, over to here, what we're going to first of all look at is a dilation. So dilated by a factor of 2 from x-axis. This negative sign means it has been reflected in the x-axis. Reflections in the x-axis change y, and it's been translated 1 unit down. Okay, this final example is looking at the transformations that take this kind of already transformed basic function back to the basic. So this is in fact our image over here. So what we've got to do to this one here is get it ready for pairing is what I call it. Okay, so I'm just going to translate or transpose this one. So y take 4 over a half equals cosine 3x take away pi on 2. That's pretty ugly there. So what I'm going to do is just put a half into that and a half into that. So I'm going to get 2y take 8 equals cosine 3x take pi on 2. Right, now we're ready for pairing. So I'm going to pair the y's with the y's and the x with the x. That's going to be y dash equals 2y take 8 and x dash equals 3x take pi on 2. Right, now what we need is the transformations. So I draw this like template, I call it. Remember, this has the transformations to turn it into x dash and this has the transformations that we use to turn it into y dash. So I need to make x dash the subject and y dash the subject, and it already is. And you'll find that that's the scenario when I turn something that's already been transformed into the basic is, it'll already come out correctly transposed. So I simply need to just copy that in to y take 8, and now we're going to list the transformations. So we've got a dilation factor 3 from the y-axis, translation pi on 2 to the left. So dilation factor 2 from x-axis and translation 8 units to the translation 8 units up. Okay, so there are my transformations.